trying to.
Actually, people do that. Okay. Yeah, go ahead.
Alright, so a lot of what we are going to do the rest of the year is write equations and lines. Okay? So it's really, really important that you have the Algebra 1 skills down before we get into the calculus. And so today, we are just going to talk about everything with lines. Right? Writing equations of lines, slope of a line, parallel and perpendicular lines, all that kind of stuff. All the lines. The 18th. Right? So, first thing to talk about is slope. We can break slope down even further by talking about just how far we move in the x direction or just how far we move in the y direction. Okay? Change in y over change in x. And this is actually the next chapter. What we're going to start getting into is called derivatives. And this is the basis of a derivative. Okay? It's just slope. So we're going to define change in x and change in y this way. Okay? Just change in y is the difference in the y coordinates between 2 points, and the change in x is the difference in the x coordinates between 2 points. Okay? We can call those increments. So, for example, if I have the points -1, 5 and 4, 7, what is my change in x? 5. The difference, the distance between those 2 points. How about my change in y? 2. The distance between -1 and 4 is 5. Alright? We okay with those? Okay, so then the next step is defining slope using those ideas. So we can say, well, slope is the change in y over the change in x. So for this example, my slope would be 2/5. Now, in calculus, if we are going to use this slope idea a lot, instead of writing the triangle to signify delta, what we actually just end up writing is an e, okay, dy dx. And this notation is going to be very, very common for the rest of the year. Okay, dy dx, or dy over dx. And all that signifies is slope. What we're going to use it to signify eventually is a derivative, which we'll get into that, is really just slope. Right? So dy over dx is going to signify slope for us. Right? So we don't really need to do another example of that.
Why did you know what? The fact that I didn't even question the fact that maybe oh my god, I'm so sorry for her. I think she's gonna cancel class with it.
Alright.
Resume.
So, slope of a line. Now, you all know what the slope of a line is. Now, another way that we are going to define this, and it's really the same thing. If we've got 2 coordinate points, okay, we can say that the slope is f of b minus f of a over b minus, oops, is that backwards in there? Over b minus a. And it's really just the same thing. y2 minus y1 over x2 minus x1. Okay. So, the next step then is to get into equations of lines. Right? So first, let's talk about horizontal and vertical lines. Right? So if I've got a point AB, right? So let's say we just have some random point, it's the point AB here, and I want to construct a vertical and a horizontal line through that point. Well, how do I write the equation of let's do vertical line first. How do I write the equation of a vertical line? X equals, right? So a vertical line is always in the form of x equals some number, right? Whatever the x coordinate of that point is. You can remember that because if you start checking points on that line, they're all going to have the same x coordinate. Same idea for the y's, right? If I draw a horizontal line through that point, it would be of the form y equals b. Right? Y equals whatever that coordinate point is. So, what would be the vertical and horizontal lines that go through the point negative 3, 8? X equals negative 3. Y equals 8. Questions on that? And now, the next idea is to write non-vertical or non-horizontal lines. Point slope, and actually this way better. Point slope is going to be our method of choice. Right? I know in Algebra 1 and maybe even Algebra 2, you focused more on slope-intercept, right? Y equals mx plus b. But in this class, we're going to use this formula line a little bit more often because it's less work. And it takes less writing, it's less work. And on the AP exam, they will accept lines in this form. You don't have to simplify it to slope-intercept. As we do some examples, it'll make more sense why that's advantageous. Right? So y minus y1 equals m times x minus x1. And so we can write equations of lines, given certain pieces of information. So for example, if I give you the points, 1, 3, and the slope of 2, how would I use this equation, this information, to write the equation of the line that goes through 1, 3, and has a slope of 2? Right, we're just Now, we can stop there. That's the answer. Right? We don't have to put it into slope-intercept form. Right? That's why using this is advantageous. Right? Because if we used y equals mx plus b, we would have to go through the process of solving for b and plug that back in for an answer. Right? This can be our final answer. Right? This is the equation of a line that goes through the point 1, 3 and has a slope of 2. Okay? So, especially when we start doing calculus and having to write equations of lines, this will make it much simpler. Now, what if I gave you 2 coordinate points? 4, 7, and 2, negative 5. How would I write the equation of the line that goes through those 2 points? She already did the slope. Right? So And we do have to find the slope between these two coordinate points, right? That we do need that piece of information in order to find it. So if you can do it in your head, that's perfectly fine. That's great. If you can't, right, you use the slope formula. Right? y2 minus y1 over x2 minus x1. So that would just be -5 minus 7 over 2 minus -4. So it's actually going to be -2, right? -12 over 6. So y minus 7 equals -2 times x plus 4. That's the answer. You okay with that one? That's really it for that one. I guess we can go through this example here. For this one, we've got numbers that don't work out quite as nice. And so try this one here. Okay. Write the equation of the line through 7, -2, and -5, 8.
Yes.
So for this one, we can stop here, right? They went a little bit further and put it into slope-intercept. Okay? We can stop here and put it into point-slope form. So they got y equals, well, actually, they moved the 2 over to get y by itself. Okay, you don't even have to go that far. You can just say y plus 2 equals -5, 6 times x minus 7. You okay with these? Alright, then let's yes. Alright. So the other thing we can do is give a line in a general form. Ax plus by equals c. Or an example, 2x plus 3y equals 15. Something like that. So, if I ask you what the slope was, what would you tell me here? What's the slope of this line? 2x plus 3y equals 15. A bunch of different answers.
Yes, all the numbers.
Almost.
Over 2?
So, almost. Why is it not
-2.
There you go. It's going to be negative. Right? In order to just see the slope of a line, we would need to put it into slope-intercept form, right? So I would get y by itself, subtract the 2x over, and then divide everything by 3. So I would get y equals negative 2/3 x plus 5. Right? So then the slope of this line would be negative 2/3. Right? So whenever we're given the general form of a line, right, if we're asked questions like the slope, the y-intercept, we would need to get y by itself. Okay? We would need to solve for y. Questions on that idea? Alright, how about a simple real life example here? Company reimburses its representatives $150 a day for lodging and meals plus 34 cents per mile. You want to write a linear equation to represent this situation and then figure out how much it costs the company if a sales representative drives 137 miles. So they say we're going to define the cost as C, so that'll be like our Y. Right? So C equals. Now, how would I represent this situation using a linear equation? Right, so this would be the slope. That's the thing that's changing. So we can say 0.34x plus 150. Then to figure out how much it costs the company, we would plug in 137 for x. 137 times 34 cents a mile plus $150 for lodging and meals. So what do we get for that? $658. Yeah.
Okay.
Yeah, I guess I should have said C of x up here for my equation. Okay. Good on something like that? Alright. Then, let's talk about parallel and perpendicular. This is algebra 1.
I'm getting flashbacks.
Right? Parallel and perpendicular lines. If we are talking about parallel lines have the same slope. And parallel lines have the same slope. So, if, let's say, I gave you this line, y equals 2/3 x minus 7, and said, write the equation of a line parallel to this one that goes through the points, I don't know, 4, 6. How would we do that? Yeah. Right, so the slope of my new line would have to be 2/3. And if I'm writing the equation of a line parallel, they have to have the same slope. So what do I do with this information? So we could, right? You could go through the process of finding the b value, but what might be a little bit easier? Point slope, right? So I can just plug this point in. So y minus 6 equals 2/3 times x minus 4. And I'm done. That is the equation of the line. What if I said, give me a line parallel to 5x minus 2y equals 8. It goes through the points negative 1, 2. How would we write an equation parallel to that line that goes through that? Right, so the slope, if we think about solving for y, would end up being positive 2 over 5? No. 5 over 2. 5 over 2. Okay. So then, same process. Okay. Use the point slope to write the equation of a line. So we would say y minus 2 equals 5 halves times x plus 1. We can stop there. Right? That's the final answer. We don't have to simplify it. Okay. The other idea is perpendicular lines. What is the relationship between slopes of perpendicular lines? Opposite reciprocals. Okay. So, let's do this same example here. But I want you to write the equation of a line perpendicular to this one that goes through this point. So what will the slope of my new line have to be? Negative 2/5.
See, I was just thinking.
One step ahead.
I knew you were going to ask that.
So you'd already done the other one.
Yeah,
and you were just,
exactly.
Yeah. Alright, so once I find the slope of this line, I would just take the opposite reciprocal and plug it into y minus y1 equals m times minus x1. So y minus 2 equals negative 2/5 times x plus 1. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Good on that idea? Last idea then is systems of equations. Okay, so given two lines, okay, we want to find a solution. What does that even mean? What is a solution to a system of equations? Finding the x and y of what? Where they meet, where they intersect.
Oh.
Right? Yeah. Okay. So the solution to a system of equations is their point of intersection. Right? So if I give you y equals 2x plus 4 and y equals negative 3x minus 7, how would you find a point of intersection? How would you solve this? Yeah, so there's a couple of different methods that you can use. Okay? One is substitution, and you can use the substitution method. So how did that work? What would we do for that?
You can do like wait, don't you want to just like for that one you do addition or whatever, or subtract. But since that y equals 3x minus 7, you should just plug the negative 3x minus 7 into the y.
Right. So let's go through both of those ways. Right. So the first one, you're saying, well, since y equals negative 3x minus 7, I can take this and substitute it in place of this y. Right? So I can just make this negative 3x minus 7 equals 2x plus 4. Solve this for x then. So let's add 3x over, subtract the 4, divide by 5. My x coordinate is negative 11/5. what do I do from there?
Now you plug in the. Oh yeah, plug in.
So yeah, we could do that, but it'd probably be easiest just to plug this into one of the equations to get the y coordinate. Right? So it does not matter which equation I plug it into. So I'll use the first one since it's got all positive values. So 2 times negative 11 fifths plus 4. So negative 22 fifths plus 20 fifths. So my final answer then would be the coordinate points. Negative 11 fifths, negative 2 fifths. Okay, so that's the substitution method. The other method was the elimination method. So I'll rewrite this problem over here. So this is also set up really nicely for the elimination method. Right? Our goal in that is to just cancel out one of the variables. In this case, I can just subtract the bottom equation. The y's will cancel. Right? So I would be subtracting the whole thing. And if there aren't any variables that match up like that, we may have to multiply one or both of the equations by a constant to get them to cancel out. But in this case, if I just subtract everything, I would get 0 over here, 2 minus negative 3x, 5x, 4 minus negative 7, 11. Then I can solve for x, so subtract the 11, divide by 5, and I get the same thing that we did in this method, right? Then I would go through the same process, just take this value, plug it back into one of the equations to get the y value. And then I would end up with the same solution. So, a couple of different ways. Right? We could either use substitution, right, where we would get one variable by itself and replace that in the other equation, or we could use elimination. Right. You guys want to try another one?